Hello everyone. In this video, I'm going to demonstrate a complete 5G setup using an open source srsRAN project which provides a Gnode B and the 5G UE functionality. So we are going to cover a lot of topics as part of this demo. We'll start with the basic architecture of our setup along with an overview of the VM readiness. Then we'll continue with the installation of the dockerized version of Open 5G core setup. We can actually use the free 5G core as well, which I demonstrated in the previous videos. But in this demo, we are going to use an dockerized version of Open 5G core. Then we will continue with the installation of Gnode B, and then we will initialize and start our Gnode B. Moving forward, we'll continue with the readiness of our 5G UE, and we'll initialize the 5G UE as well. Once our whole setup is ready, then we will do some basic UE traffic testing. And finally, we will see how we can use this setup to do a multi-UE testing as well. So let's get started. So this is the setup what we are going to build here. So we have an SRS UE which is part of the srsRAN 4G project. The reason that we're going to use a different project here because the srsRAN project, which actually provides the Gnode B, it doesn't include a UE application. So that's why we are going to use the srsRAN 4G project, which actually provides a prototype for the 5G UE. Then as part of the 5G core, we are going to use an Open5GS. We can actually use the free 5G core as well, but just for this particular demonstration, we are going to use an Open5GS dockerized version. Let's look into the srsRAN project documentation. So if you look at the documentation here, it does provide almost all the instructions and the procedure what we are going to use here. So if you want to get a bit more information, you can always refer to the srsRAN documentation project and the GitHub repo as well. So if you look into this documentation, it actually provide a couple of different solutions to build this setup. So it has an over-the-air setup, it has a ZeroMQ based setup, it has a multi-view emulation and a bit of further troubleshooting and the limitation which actually is part of the srsRAN project. So over-the-air setup actually it requires some kind of a RF front end, so you can use a different hardware to actually provide this RF front end connectivity. But since we are not going to use any kind of a hardware, we are going to use the ZeroMQ based setup. So what actually it does is it actually provides us a simple virtual radios. So it will be using a ZeroMQ based RF driver in both the Gnode B and the SRS UE, and that's how it's going to actually use the air interface. So to build this virtual machine, actually the requirement here actually is already mentioned that it needs an Ubuntu 22.04.1 long-term system release, and then we need to install a Docker as well, so we can actually use the dockerized version of Open5GS. So going forward, we are going to actually use our terminal and we'll start the installation and the readiness for the virtual machine. So let me bring the terminal here. So this is our terminal. Let me just show what's the. So I have already installed Ubuntu 22.04.1 latest release, and this is a partition, and this is the memory what I'm using here, overall 8 a bit of RAM. So what we are going to do is we are going to install a Docker here. So you can refer to the Docker the documentation page, where I have actually just summarized all the instructions on my repo. So you can refer either of the pages to actually install the Docker. So is done. Let's run the next, add the repository, and finally let's install the Docker Compose. And once it's done, we will just test it using the running a simple Docker container, hello world. So what it'll do, it'll just pull the image and then run this container. So let's test. Alright, so we can see the hello from Docker, download the image. So we can list the images. So you can see here it has download the image with that latest tag. And if we see this was the container which was created and now it's been exited. So we can simply remove this. And we can remove the image as well if required. So now we'll see it's gone. So does the container, everything. So now we'll move on to starting the Open 5G core for our for this dockerized version. So what we'll do is we will clone this srsRAN repo, and then we will start our Open 5G core using this Docker Compose command. So let me just clone this repo. If you see here, we have this srsRAN project which has been cloned. So we'll go inside the srsRAN project and then the Docker. So here you have the Docker Compose file and the Docker file as well. So we'll just run through a 5G core. We'll start. So it will pull all the required images. It'll take some time. So once this is up and running, this is how it will the output will look like, where it will build the images, and then finally you will see the container created and attaching to this container. So the later on in the next phase is when we start the gnode, when we build the gnode B and we start the gnode B. So you will see the gnode B sending the request, and then you can see in the logs as well that the gnode B is now connected. You can actually get the traces and things, so we will see this in the coming sections, that how we can actually take the traces and the pcaps as well. The first time installation, it does take some time, but going forward, when you are going to stop and start again this 5G core setup, it should be rather quick. If you'd like to see what's really is happening here, you can actually look into these Docker files and the Docker compose, these YAML files. It'll give you a lot more information, and further actually you can go through into the Open5GS folder and you can find a lot more information, the configuration, the environment details as well. So if you want to play with the environment, you can actually try to modify these files and try to see what's really happening, and as per your specific requirement you can modify these files. So our first time build roughly took around 25 minutes. It seems now it's up and running. So subsequent is running the 5G core, it will take very less time, because the first time it has to build the complete setup. So that was the reason it took much longer. So in the next section, we'll build and compile our Gnode B, and then we will see how that's connected to the our 5G core. So first of all, let's install the dependencies. So I'm going to install all the dependencies. Okay. Since we already have the srsRAN project cloned, so we're not going to actually do the git cloning again. So we'll just directly go inside the srsRAN project and we'll build the project. And this will make our Gnode be available. What we need to ensure is that we actually have this flag enabled, which actually going to use the ZeroMQ. If we don't use these flags, then the Gnode what we are going to build is not going to use the ZeroMQ. So that's something we need to ensure. Let's create the build directory. I'm going to build the project. And now actually compiling it is gonna take some time. So I'll just start this, and probably I think I will truncate this the complete output to keep the video a bit shorter. So the build is now completed. It roughly took around 1 hour 45 minutes to complete this the project build. So now if we look into the apps, we can see the G-Node-B application is available. So let's make this. So this is our G-Node-B app. Now let's make this available globally. So we'll copy this to our user bin path. So now if we look into the, so this is our G-Node-B application, SRS G-Node-B application. These are all the sub commands and the which can be used along with the G-Node-B application. So there are a couple of ways to actually run this G-Node-B application. We can either pass the arguments and as part of the configuration, or we can use a configuration file. So the configuration is available on the srsRAN project documentation. So either we, so what I've done is I've copied these configuration files and made it available under the path. So what I'm going to do is I'm going to use the G-Node-B ZeroMQ YAML file and pass through as a configuration file in my G-Node-B application. If you look into the G-Node-B app YAML file, it has the AMF address, it has the radio interface device drivers, the details, and the cell related configuration, where you can see is the NR band 3 with the channel bandwidth of 20 megahertz and SCS of 15 kilohertz. And the PLMN what we are using is the test PLMN, related tag configuration and related information. Here you can see the log files that will be generated in the temp file, temp folder, and the pcaps. So we have enabled the pcap, so the pcap will be generated under the /temp directory as well. So let's try to start the application. So this is a very simple command to start the application. Okay. Okay, so let me just change the folder so I can keep with my my GitHub repo, whatever I have configured there. Okay, so let's run this again. Okay, so now you can see that so now our cell with the PCI 1 and with the 20 megahertz bandwidth is now available, the UE, and it's connected to the EMF. So we can see here in the logs, so actually the G-Node-B on the N2 interface accepted this NG path module using, and the interface what it used was the N2 interface. And if you'll see in the traces in the pcap, you will see that the NG setup request was sent and the setup response was given, and we have the G-Node-B now available. So you can see the number of G-Node-B now is 1. So this is something. If you want to enable the trace, we can simply start the T, and if you want to disable the trace, we can again simply type the T, and then we can. These are the ways we can enable the traces, and we can look into the packet capture. So now in the next section, we are going to actually similarly we're going to build and compile the SRS UE, and that will be a 5G UE device. simulator that we are going to use for our testing. So let me start the next terminal. First of all, we are going to again install all the dependencies. I'm going to remove the YQ. As we mentioned earlier, that we are going to use the srsRAN 4G project for the UE prototype. So we are going to actually clone this srsRAN 4G project. Let's wait for the dependency installation to be completed. Right, so let's clone the srs 4G project. Okay, now if you see, we have the srsRAN 4G project as well. Let's go inside, make the directory build, and let's get the CMake list. Again, we need to enable the ZeroMQ, so that's important. Right now we are going to make the complete project build, so it's gonna take some time. Probably I will if it takes much longer, I'll truncate the video to keep the video short. So it took roughly a little more than 1 hour to have this complete srsRAN 4G project built. So what we are going to do is we are going to actually make the SRS UE application global. So we are going to copy this into the user bin path. And the next we are going to add, we are going to actually have a different network namespace for the UE traffic. So this will isolate our UE processes from the rest of the Linux processes. So let's create a different namespace. So we have one. Now we are going to start our SRS UE application. Just like we had this gnode B application, the UE application also, we can actually pass the parameter as part of the argument, or we can use the configuration file. So I have all the configuration files actually available under the srsRAN config folder. So I'm going to use one of the configuration file, which is the UE ZeroMQ.conf file. If we look into the just a minute. So if you are going to look into the UE ZeroMQ file, here you can see actually we have the EUTRA configuration, we have the NR configuration. So we have configured number of carrier as a 0, so we have disabled the EUTRA. But for the NR we have configured the band 3 and the number of carrier as 1. Similarly, we have given the physical resource blocks of PRBs, the number of PRBs, and we have enabled the PCAP. So what kind of a PCAP we are going to take, and we have the log also enabled for under the /temp directory. So if you go further down, we have the other configurations as well, which is the NAS, and here that's where we actually have defined the gateway as the network NS, where we have actually given the namespace which we have just created recently. So it's going to create the tunnel interface under this network namespace. So let's try to run our SRS UE application. So now it's trying to attach. Okay, you can see that. RAG procedure was completed, random access completed here, the RRC connected, PDU session establishment. Here we got the IP which has been assigned to the UE, and the if we see the RRC NR reconfiguration is also successful, so it's been attached. So here now you can see actually the gnode B, we can start seeing the trace for the uplink and the downlink direction. Here if you see the core trace is the core log, we can see actually the IMC has been connected, and here you can see all the related informations related to the IMC and the IP which has been assigned for this particular APN, SRS APN. So now what we are going to do is we'll do a very basic testing. So before we do the testing, we actually have to have this the reverse route added on our Linux host towards the APN. So this is the UE IP pool which has been actually given in the core network. So we need to add a reverse route. And next we are going to actually add the route, the default route, which will be pointing to the 1045.1.1. And this route has been actually added into the namespace UE1. This is particularly for the UE. Now if we'll try to test the ping, and we will see the responses. Similarly, actually we will try to enable the terminal traces on the UE as well. So here you can see the RSRB, the signal strengths for the UE for the on the NRV, the PCI1. So let me start the if you see here at the moment that the downlink and the uplink is everything is 0 here. So now we are going to start the basic ping, and you will see the packets. So now you can see the traffic starts appearing in the on the uplink. And you can see the band rate. Now if we want to test the downlink, we actually have to ping to the UE IP. So this is the UE IP which was given to us by the core, which you can see here. So now you can see again the downlink and uplink is 0. Now we are going to start the downlink towards the. Now you can see that the traffic start appearing for the downlink as well. Now if we want to start the iPerf for the throughput testing, we can do that as well. So let me open another terminal and let me start the iPerf as a server. Okay, just give it a minute. So what we are going to do is we are going to start the iPerf as a server. Okay, so we need to install the iPerf. So first we will start the TCP stream. Okay, let me start the iPerf server. So now you can see we are getting the traffic. And if you see here, we can see the traffic here in the downlink and the uplink. Now we will start the UDP stream. again we can see the relevant traffic. So this conclude our initial demo for the srsRAN project with a single UE. So in the next section we are going to actually go through the multi-UE setup, and we will see how we can actually test multiple UEs at the same time with attaching all the UEs to the single G-Node B and the core. So as part of the multi-UE setup, we need the changes in almost all the components. So first of all, actually we need to make the changes in our Open5G core. So at the moment we have a single subscriber configured in our subscriber database. So what we are going to do is actually we are going to load this subscriber database CSV file. So if you look into the srsRAN, the project documentation, so here they have an option given with the multi-UE emulation. So if you look into the configurations, all the configurations are given actually. So here first of all actually we need to install the GNU radio companion. So this will allow actually run through the flowchart, which will allow us to actually connect to the on a multiple port on the ZeroMQ. And then actually here we have the subscriber DB CSV file. So I already copied this file into my host path. So I will be saving this configuration file under the Docker project configuration, and then I will add it to allow, instead of a single subscriber, I will allow that to actually use this subscriber db.csv file. The next actually we have modified a very basic configuration in the G-Node B side as well. So we actually added the number of preamples, which will allow actually connect a multiple REST procedure at the same time. Then on the srsUE, as we mentioned earlier, we actually need to have a namespaces configured. So first of all, actually we need a multiple namespaces for the multiple UEs. Then for each UE we will need a different USIM data, which actually require the IMSI or the K values and all those parameters. Then the pcap and the log file name, because the log file and the pcap has to be for each and every UE that needs to be configured differently. And then the port mapping that needs to be configured for the ZeroMQ driver. So this is all the steps actually I have already mentioned here. So let's start actually on the terminal and let's try to build this. Before we actually start, let's actually stop all the components. So let's stopping the container here. Let's come out of the G-Node B. And you can see the pcaps are also stored. So once we complete this video, we'll go through this the pcap actually, that how these pcaps are actually generated, how they look like. So you can see we have stopped the UE, we have stopped the G-Node B and the core. Since we have a multiple UEs, we will need more terminals. So let's add a bit more, a couple of more terminals. So let's start modifying the let's check first. We still have the, so this is my subscriber db csv file. So I'll just copy it into the srsRAN project Docker folder, and then we need to edit this file, environment file, and let's comment this out. And Okay, so let's start our code again. You don't need to build. So you can see this time actually it started very quickly. Let's wait for this to complete it and then we'll modify our. Okay, so this is up. So here you can see seems already okay. So now for the gnode configuration file, as I mentioned earlier, I already have all my configurations in this folder. So this is the configuration file which I have that was with the minor modification. So I have already added the configuration file here. So we are going to run this configuration file. Okay, so I enable the terminal traces, and you can see now we have a number of gnode be now available is 1. Now let's move on to the UE configuration. So first of all, actually we need to add the network namespaces. So let's check. We should already have one network namespace from the last testing. Yep. So we'll add another two. Now we have the 3 namespaces here, and now we are going to actually. So if you see here, I have already copied all 3 configuration files for the UE1, UE2 and UE3. So we are going to run one by one in a different terminal. Okay, so all 3 are trying to attach. So now what we need to do is we need to actually have the GNU Radio Companion installed. Okay. Okay, let's check here. Okay, so it's just GNU Radio. Just give it a couple of minutes. So ideally, we should have installed the GNU Radeon first before we actually starting the components. Save us a lot of time. Alright, so GNU Radio has been installed. Now let's run the okay. Seems it's loading the file. Right. So this is how it looked like. So what we have here is the complete flow, which was actually as also is the multi-use scenario configuration. And now what we need to start the flow. Now you can see the RAS process is completed, the random access complete, the RC connected, PDU session establishment completed. So this is the IP is given to the third UE, the IP given to the second UE, and this is the IP given to the first UE. Here we can see the PCI, the channel quality index, correlation code schema, everything. So we have the three UEs connected. And now to do is we need to again add, so we should already have this, the IP route. So the reverse route is still there, so we don't need to add, but for the each UE we do need to add this. For the UE2 and for the UE3. And now if we test, so we can see for the UE1, for all the other UEs are the values are 0. And now, so with the UE2 we can see now, and with the UE1 it should be 0, UE3 as well. So it's only with the UE2 now. Similarly, now with the UE3, so this is our UE3. Okay, this is the one, our UE3. So now with the UE3 we can see the traffic. So this is a very basic simulator, and this is a very scenario where we can actually test the multiple UEs at the same time using the GNU radio. Now if we want to see the traces, so let's actually let's stop all the UEs. So we can simply type Q and we can quit. Same time we can shut down our simulator as well. Let's stop the other UEs as well. So we can see that traces are actually being created under the /temp folder. And now we look into the trace for the Gnode B as well. So here you can see, so all the pcaps are actually being generated here, and the log files. So how the traces look like? So let me actually pull out a couple of traces which actually. So this is how the traces will look like. So here you can see the different SIB and the RRC messages as well. So you can see all the RRC messages, their context. So this is the RRC setup request. 1 second, and here you can see the registration request being sent, the piggybacked under the RRC a setup complete. And here you can see all the nice messages are also as well. So these are very handy PCAPs actually if you want to look into these traces. And then this is the ng setup request response and the messages towards the so this is the ng AP trace. So here you can see all the messages and the parameters was been sent. Initial registration request and then the authentication, and here this is your PDU session so setup request. So that's about it. I would say actually try to do a bit more testing, so try to modify there. So this actually comes with a lot more configuration, different type of configuration as well. So if you look into the srsRAN project, our project, here you have the different configurations. So they have given a lot of different kind of configuration, but unfortunately I think if you look into the limitation for our the srsRAN for the ZeroMQ, so the UE actually has the limitation that actually it only supports the 50 subcarrier spacing, and that's the bandwidth which are actually limited is to 5, 10, 15 and 20, so it doesn't support more than 20 megahertz bandwidth. So but if you have your own UE and if you want to test this out, you can actually try to configure the G node in a different configuration, and then you can try to test it out. For example, here you have the NR band N78 100 megahertz configured or 2x2 MIMO, and see only different configurations there, so you can check this out and you can make a different configuration and try to test it out. Also I would say actually you can use our free 5G core, the previous demos, and try to integrate these G node B and the towards this free 5G core and test this out. It will give you a better understanding on a different parameter, what role parameter that needs to be configured from the integration point of view, and then you should try to test this SRS UE and the SRS G node B project and try to integrate with this free 5G core. So I will conclude the videos here and look forward to see you in the next upcoming videos.